This is a relatively quick video to show how to build bucket-style chairs. I've used the Eames Armchair as an example, but this can be used for a variety of similar chairs, such as the Noomi Chair, the Barclay Chair, the Striad Chair, and possibly the Noomi Chair. The techniques being shown in this video probably won't work well for something like the egg chair. These techniques work best for chairs that have well-defined surfaces that are blended together with fillets or boundaries. For example, it can be seen that although everything is nicely blended together, the seat pan, the arm area, and the back are all distinctive areas that are easily identifiable. This is in contrast to the egg chair, where it's hard to tell where the armrest and the back or the seat begin or end because they flow together as one single form. All of this becomes even more obvious when I turn on the tangent edges of the chair. We can clearly see the back surface, the seat, and the arms, and the surfaces that blend them together. Considering how curvy this chair is, there really aren't all that many surfaces to make this chair model a convincing rendition of the actual chair. To make this chair model, I had to make several assumptions and also some shortcuts. But before I show you those, I'm going to roll back the model to the raw surfaces before any thickening has been added. Here's the surface model before I mirrored it and thickened the surfaces. If we look at a side view of the model, we can see that I made the assumption that the armrest is perfectly horizontal and that the lip running around from the headrest all the way down to the area where your legs would go is a non-compound surface that in the headrest area flows in a Z direction, in the armrest area is flat planar, and in this vertical area of the armrest flows in the X direction. These types of surfaces are called ruled surfaces because they can be flattened, unlike a compound surface. The only compound surfaces on this lip area are the very front lip of the chair where your legs are, and this transitional zone from this part of the lip to this part of the lip. If we look at the chair from the front, we see that the lip is edge on in the headrest area, and if we look at it from the right side, we see that the lip is edge on in this area. Other assumptions I made was that I could build the back, seat, and arm area separately and then blend them together with a fillet or some sort of a boundary surface. I also assumed for expedience that these surfaces could be built using sweeps instead of boundaries, which got me around the problem of having to make a lot of projected sketches, which may not be appropriate for your own chair, but it saved me time for the video. Because of these expedient measures I took, some of the features in the finished chair will not exactly match the layout sketches. However, the layout sketches will still be parametrically controlling the chair. The last thing to consider is that I have made up all of the dimensions that you will see in this video. I did not measure an actual chair, nor did I measure one from any photographs. I just sort of eyeballed the photos and made the proportions look somewhat like the real chair. Now let me roll back the model to the layout sketches. After modeling several chairs, I've come to the conclusion that the first sketch should always be the side view of the chair because the shape of the chair back and the chair seat can be clearly seen in this view. That means that the side view layout will be somewhat controlling the front view and the top view. Now, whether you should do the top view next or the front view next is a matter of choice, and you can make good arguments for both. Whenever I can, I like to pretend that the surfaces meet at sharp corners, such as I've drawn here between the back and the seat area, and that later on some sort of a blend will be put in between them. Sometimes what I do is actually draw in a radius to remind myself that there will later on be a blend. You also can't always know what the exact shape will be of a certain surface or edge when drawn from a particular viewpoint until you've actually got all the surfaces built. So in some cases, some of your sketch will be just a guess. For example, down in this area where the front lip is located, I've got a radius going from the vertical arm to the center of the chair, right where the front of the lip is. The shape of this radius is a total guess, as is this radius here as well. This will become more clear when we get all of the surfaces constructed. These construction lines were added to make it easier to align the later views, such as the top and the front, with this side view. You also need to know what your lines actually represent. Are they a line that's actually representing a 2D line on a flat plane, or are they a 2D representation of a 3D line? For example, this edge here and this edge here actually represent the shape of the seat in the back on the front plane. These would be two-dimensional in real life. This curve here, coming across here, down, and then finally curving to this point, represents a complicated 3D line seen in 2 dimensions. I wish there was a way to color these lines differently in Solidworks, but I don't know of a way of doing that. The next layout I chose to make was the front layout. And here we can clearly see the shape of the headrest and the flat armrest and the shape of the seat area when viewed from the front. Another shortcut I took was to make these curves simple 3-point arcs instead of splines, which they probably should be. In fact, the only spline that you see in this view is the shape of the headrest. This area you see here is the front lip, and once again I've drawn the sides and the bottom of the lip coming to sharp corners and put some fillets in just to remind me that later on this will have to be radiused on this edge. The final layout is the top view, and here we see the shape of the armrest from the top, see the front lip from the top, and here's the shape of the headrest from the top. These curves for the headrest are just a guess, which will become clear later. But the endpoints of the headrest are where they need to be. This curve here represents the shape of the chair back at the level of the armrest. This edge of the armrest and this edge of the armrest have been drawn as straight lines. I suspect that the real chair has a slight curvature to both of these lines, and if you are building the Eames chair, supposedly you've seen the real one and have noted that. We can now see how the side view of the headrest aligns with the front view of the headrest. We can see where the top view of the front lip aligns with this point, and the lower edge of the front lip aligns with this point, and how this curve representing the bottom back edge of the seat aligns with this point. Finally, we can see how this point in the top view of the headrest aligns with this point in the side view of the headrest. We can now move on to making the major surfaces of the chair. For expedience, I will be making the seat back, the seat bottom or seat pan, and the armrest area as swept surfaces. This may not be appropriate for your chair, and it might be better for you to make boundaries with edges that are controlled by projected sketches. But as I've said before, I'm trying to make a simplified version of the chair and simplify it for this video. To make the swept surfaces, I first need to start with some starting planes. I'll have a plane for where the seat surface will start, and that will be starting right at the end of this point in the side view. I will need a starting plane for the armrest. That will be a plane that's starting at this point here in the side view. And finally, I need a plane for sweeping the backrest, which is going to start on the top surface of the armrest. So I will start by sweeping the backrest of the chair. So rolling forward, we can see what that sweep looks like. In order to make that, I used a profile copied from the side view sketch and I purposely stretched that profile a little bit higher and a little bit lower than it originally was in the layout sketch. I did the same thing for the path sketch, where I copied this line from the top view and I purposely stretched it out an extra 2 inches. The reason for this will become obvious shortly. The seat surface has a profile that is copied from the front view, this curve here, and again I've stretched it out a little bit. And the profile sketch for that, the path sketch for that is copied from the side view again. And once again, I've stretched this out a little bit beyond its original limits. When we turn off the sketches and look at these two swept surfaces, we see that they intersect each other. Finally, the vertical arm surface utilizes, from the front view, this line here, which has been copied and stretched all the way up so that it matches the top edge of the seat back sweep, and stretched all the way down to meet the bottom edge. The path for this sweep is copied from this inside edge of the arm, and once again it's stretched out longer than it is in the layout sketch. If we look at all of the surfaces now, we see that they intersect each other nicely and they line up at the top and at the bottom. This becomes necessary when you want to trim these using a mutual trim. Otherwise, sometimes the trim gives results that are undesirable. So we're going to now trim these three surfaces together, and I'll just demonstrate that using the mutual trim. Go to Trim Surface, we select the mutual option and select all three surfaces. I'm going to use the Keep Selections option, highlight the Pieces to Keep box, and I'm going to use the Show Excluded Surfaces option. So when I select a piece that I want to keep, it's actually going to disappear, leaving behind the bits that I don't want. Click the check mark. This is going to be my basic form that's going to form the bucket chair. I now need to put in some blending surfaces between these main surfaces so that we no longer have any sharp edges. One way to do that is to trim out the sharp edge and then build in some boundaries to blend all of these main surfaces together. It's going to be a little bit of work. It might be the right way to do things, but for the purposes of this video, I'm going to see if I can use an easier method, which is to use a fillet. So rolling forward here, we'll take a look at that fillet that I made, and we'll edit that feature. And we see that, first of all, I've used a multi-radius fillet, which allows me to have a different radius on all three edges. Also, what I do not want to have happen is have these fillets run into each other with sharp corners, because then this will not have a nice, soft, organic look in the corner. What I've done is use the set back option to get these fillets to blend together in this zone more nicely with a curve between the tangent edges. I've also used the curvature continuous option. Now if we go back to the setback parameters, we see that what I've done is set the setback on all three edges emanating from this vertex to 2 inches. What that means is if this fillet and this fillet were originally going to blend together here, the blend point actually gets set back by 2 inches in both directions, giving this curved line, and doing the same in all three places. I can actually have a different setback in all three areas. If I want to eliminate the setback, which I'll do here, you can see what happens is these blend together with hard corners. This will still be a nice blend, but it just isn't quite right for an organic looking chair like this. So we will leave the setback option turned on, and I will cancel out of this feature, and now we can see how these fillets blend together with this sort of a hexagonal zone, giving us a nice organic, sort of a soap bar like corner. However, if I roll my views around, I see that this corner is not very nice looking. It's kind of flattened out in some areas. What I'm going to do is delete this face and build a new fill surface in this area. So I do that by going to my Surfaces tab, Delete Face, and I use the Delete option. I simply click on that face to eliminate it. Now build in a new fillet, or filled surface rather, clicking on the 6 edges of this patch boundary. What I want to do is make all the edges have the equal curvature option, and then finally click out of that. We'll look at that and we see that this is puffed out a little bit more nicely compared to the original corner. If we want this to puff out a little bit more, we can always add a constraint curve on a plane going through here or maybe through here, or we might even be able to add a 3D point sitting out here somewhere that will pull this surface out a little bit more. The next step is just to reknit this back into the main body. Now we have a nice organic looking bucket shape that can be trimmed to give us the final shape of our chair. Let's just look at that without the tangent edges turned on. You can still see it's a little bit flattish in this area, so as I said before, constraint curve might help out there. So the first trim I'm going to do is to trim out the shape of the headrest and the top of the armrest. Whenever you're doing a trim on a surface, you want to use the layout sketch that is looking the most directly at the particular feature you're trying to create. What I mean by that is if we want to have a nice accurate shape of the headrest, we should be trimming it from a direction where we have a very direct view of the headrest. That would actually be the front view. So by copying this curve and this straight line and using it to trim away this surface, we get something that looks like that. Looking at the top view now, I want to create this curve on the front edge of the chair. And since this curve is most directly seen from the top, that's the view I want to use to make this trim. That was done by copying this edge and stretching it out a little farther to completely trim this all the way out to the outside. The last trim I need to do is the one that angles the armrest back a little bit. And again, the most direct view of that in this case is going to be the side view. So we are trying to get this tilted back edge, and we need to blend it in to this edge here, which is the front curve. Now you can start seeing how some of these curves were just guesses because this edge here obviously is not really matching this edge very well. To do this trim, I'm going to copy this edge, but from here to here, I'm going to build in a little spline that's going to blend them together nicely. So let's take a look at what that looks like. So here's my copied straight edge. Here's a 2-point spline added from this point to this point here. And I made a copy of this edge here because I was having trouble making this spline tangent to this edge. And sometimes it's easier to make a tangent to a copied line in the sketch. So I copied this line from this lower edge, copied this line from my right layout, and then drew in a spline which is equal curvature at both ends. So there's my trim. You can see this is a nice smooth looking curve through here, and we'll take a look at that now from the top view We can see that this is a pretty nice looking continuous curve going from the arm to the seat area. If we look at our entire chair and turn our sketches back on, now we can see how some of my curves don't really match up with the layouts. Like this edge of the headrest does align right at about this point here, but you can see it diverges quite a bit in this area. This upper edge does align. This edge here does not align in this area, but it does align in this area. This is because I wasn't building any of these edges as projected sketches from two different views, but instead was using a sketch from one view to trim an already created surface. And as a result, we just get an edge shape from the top view here, which is different from the shape that we guessed originally. The same mismatch can be seen from the side view. This aligns right here, but this trim that we just made does not align at all with this sketch that we made a guess on. But it does align right at this point here. And similarly, we see that this bottom edge aligns here, but it diverges in this area here because, again, I drew this curve in just to remind me that later on I was going to blend this together. And then finally, if we look at the top here, we see that this edge here of the headrest doesn't really match up with this curve that I drew from the side view, which again was just a guess. If you're planning on making something like a Barclay chair that has a big opening between the seat and the back, this would probably be a good time to go ahead and make the trim that forms that opening. After you make that trim, you might want to delete any leftover little pieces of surfaces, and if necessary, take the seat pan area and extend it out a little bit farther and then retrim it to the shape that you want. The next major surface that we need to build is that lip surface that starts at the headrest, goes down along the armrest, and finally finishes down at the front edge of the seat. We're going to have to do this in stages. The headrest area could be made by taking a straight line on the right plane and just sweeping it down along these two edges using the keep normal constant option. However, I found that when I tried to do that sweep, for some reason it was failing whenever it got to this point here. So a workaround was to use something called a ruled surface, and I can use a sweep option for that. I'll show you what that looks like. So this effectively has taken a straight line and swept it along these edges that I selected, and it has made the sweep go perpendicular to the plane that I selected. So we'll take a look at the feature manager for that. So what I've done is selected the front plane, I've used the sweep option, and this is going to make a swept surface where the entire surface is perpendicular to the selected front plane, and it is sweeping along these two edges that I've selected. I've also specified how long this edge is going to be, and I arbitrarily chose 4 inches, which is long enough to give me something to then trim back later on. The armrest surface is just a planar surface sitting on the plane that I had already established right here. And if we look at this from the top view, I've purposely overbuilt this surface so that later on I can trim it to the shape that I want. I'll go ahead and trim these two surfaces using my top view sketch, but you notice that because this line is so far off of the real line, I'm going to go ahead and redraw this back edge to look a little bit more in harmony with this front edge. So if we go back and take a look at what that sketch looks like, you see I've drawn a new spline going from this point to this point, which just pulls this edge forward a little bit to look nicer with this edge. This portion is copied from the top. This arc is copied from the top layout, as well as this straight line, giving us the headrest and armrest area a completed look. I now have 3 more zones where I need to add the lip. This descending portion here of the armrest, this curving portion, and then the bottom front edge of the seat area. I'll start with this edge here because that's an easy one to do, and I'm going to use the ruled surface option again. So we'll go to ruled surface, sweep option, and then I want to choose the plane that this surface is going to be perpendicular to. In this case, I want it perpendicular to the right plane, and I'll select the edge that's going to be swept, and I'll just add an arbitrary dimension here. And the nice thing about this option is that I don't have to draw any extra sketches on any new planes in order to create this surface. And you see that when I look at this right from the right side, that surface is edge on because it was made perpendicular to the right plane. The front lip of our chair angles outward quite a bit and is probably going to be a compound surface, so it's not going to be suitable to make a ruled surface here. So what I've done is copy this line from the right layout and swept it along this edge. And I've purposely stretched it out a little bit beyond the original layout so that when I trim this, I will get a nice clean trim. So now looking at this from the front view, I want to trim back both of these surfaces to their final shape and then patch in a transitional surface that will go from here to here. So the trimming sketch is going to come from my front layout. These 2 curves that just meet at a sharp corner. So I trimmed those, saving this piece and this piece. Now what I can do is build that transitional zone, which will actually be a boundary going from this edge to this edge, using this edge, and then we want to have one last edge out here to control the outer edge of this boundary. To do that, what I've done is drawn a 3D sketch going from this point to this point, and it's equal curvature at both of these edges. Let's take a look at that. This is the final boundary surface, and we'll just take a look at that spline I drew in 3D, going from this point to this point, equal curvature to this edge and to this edge. And when we look at this from the front view, we can see this is a nice looking curve from the front view, and if we look at it from the side view, it's a fairly nice looking curve also. And we can further see that this curve doesn't really match anything that I drew in my layouts. Now we have all of the main pieces of our chair. I'll knit these together to form one body. Now I've got one more task to do, which is simply to add a fillet to this edge. And this is equal curvature on both ends of the fillet. Now some chairs really do have a lip that's very flat like this as it goes around. Others have a lip which has a crown to the surface, giving it a more compound curvature shape. The lip of the Eames chair does have a crowned surface, but that doesn't mean that the work that we've done here is for naught, because we will be able to use this inside edge of the lip and this outside edge of the lip as guides to create our new crown surface running from the top down to the bottom. You might think that the best way to do this is a big boundary with lots of cross-sectional sketches all along the way, but an easier way to do this might be to use a sweep. I'm going to go through the actual steps for making this crowned surface. One problem with making a sweep along this area is that you can see that the width of the sweep profile would have to get wider and then narrower again as it runs along the length. Normally the profile remains a constant in size, but there is an option in sweeps that allows us to have a varying profile, and I'm going to go through that process. we're going to draw the profile on the right plane and start it up at the top of the headrest. So on my right plane, make a new sketch, and the crowned profile is going to be very simple. It's going to be just a 3-point sketch. And instead of adding a radius to this, I'm going to add a height dimension to control it. I'll just make a tangent line here and give this a dimension, in this case, of about 0.15 inches. What's going to happen is we're going to sweep this profile along 2 rails, this edge here and this edge here, and no matter how wide or narrow this profile gets, it's always going to be 0.15 inches tall. That way, as it gets wider, it won't get taller, or narrower, it won't get shorter, which is what would happen if we took this dimension out and added a radius instead. So we've got this profile. We'll finish that sketch. And now I'm going to do the sweep by selecting this profile. And I'll turn off my sketches so I can see my edges. And I'm going to use this inside edge as my path. I have to piece it together out of several edges, so I'll use the selection manager and choose all of these pieces of the edges. You might have a very fractured edge, so make sure that you get every last little piece in there or the sweep will not work. So clicking on the check mark, I see that I'm not even getting a sweep just yet. And then I'm going to open up my guide curves box, and I'm going to use this outer edge of the lip as the guide curve. So once again, I want to use the selection manager. Make sure I get all of the little portions here. Check mark. This takes a moment for it to figure out what it's doing, and we see that the sweep is only going to here. It's not making it all the way down to here. All we have to do is, under our options, under Profile Twist, select Follow Path and First Guide Curve. This is a complicated sweep, so it'll take a moment to figure out. Now you see the sweep going all the way down to the bottom. You can see how it's wider here like it's supposed to be, narrower here like it's supposed to be, and we'll finish this. And you can see that it's always the same height everywhere. This 0.15 inches high. And I will also mention one other option that should be checked probably, although I don't think I did. Just for good measure, go ahead and check the option Merge Tangent Faces. It doesn't seem to be making a difference in this case, but by doing so you'll avoid having this surface being broken up into lots of different pieces. Now we are pretty much coming into the home stretch. I did discover when I looked at this sweep more carefully that the sweep did not quite make it all the way to the right plane down at the bottom here. So I'm purposely going to extend this edge and then use the right plane to trim it back again. So if we look at this again from the front view, we see that this is now a nice straight edge that ends exactly on the right plane. If we don't do that, we'll have a funny crack when we mirror this over. The last thing we need to do before mirroring it and thickening it is getting rid of this original lip surface that was used to help create our swept surface. All we have to do is use the delete surface command. You want to probably hide your swept surface when you do this. So we want to use the delete option, not delete and patch or delete and fill, and just click on all of these surfaces to get rid of them. Make the swept surface visible again, and then knit everything together. The last little bit to do is just add a fillet along this edge to blend everything together. I use the chord width option so that this looks like a consistent width going all the way from top to bottom. The one little problem with this is that if you look at the real chair, it looks to me like the fillet gets very large down in this area for a nice big blend while staying more of a tight radius up here. So it might be more appropriate to use a variable radius along the entire edge, allowing it to get bigger here. Or what you could do is maybe use the chord width fillet, but then come back and trim out these areas around the corner into here, and then just build a new boundary surface in that gives you a much more softer blend. Now I mirror the chair, and you need to decide when you draw your sketches whether your sketches represent the top surface of the chair or the bottom surface of the chair. I decided that those surfaces represented the upper surface of the chair, so I'm going to thicken it going downward. There's my thickened chair. I don't know what the true thickness is of this on the real chair, but I use 0.15 inches to thicken it. Seemed like a pretty good guess. And then finally, I want to get rid of this sharp edge. If you can try to use a full round fillet. I'll show you what that looks like. That's this option right here. So in the first box we put the upper surface, the second box we put the edge surface, and the third box we put the bottom surface. With tangent propagation, it should propagate the fillet all along the entire perimeter of the chair. It's a big operation, but you can see now this is nicely rounded over. If you can't make that work, then you can put in a small radius on the upper edge and a small radius on the lower edge. There's our chair, which looks pretty much like the real thing, although again I'll mention that my dimensions are completely made up, so the proportions are probably off a little bit. Here we see how this lip kind of angles forward just at the bottom and can be seen more edge on in this area here, and is more edge on in this area here. Some of you might be building a chair that has a lip like this, but the lip is angled up more like this. So in that case, it's probably best to just take an angled line and try to sweep it down, and then later on blend it in with whatever the shape is of the lip in these areas here. So that's the procedure, and I think you can use this basic approach, as I mentioned before, to do several different chairs.